Three persons A, B and C participate in a competition. The chance that A will win is twice that of C, right? So the chance that A will win, probability that A will win is twice that of probability of C. And the chance that B will win is 4 times the chance that C wins. This is the second information. Right, only 3 persons are competing. Find the probability that A, B and C respectively will win the competition. The question is not that A, B and C, all of them will win the competition. It is you are supposed to find the chance that A will win the competition separately, B will win and C will win. Okay. So since only 3 persons are competing, we know the total probability is 1. So probability of A plus probability of B plus probability of C is equal to 1, which implies this can be written as 2 times probability of C, and this as given in equation 2 can be written as 4 times probability of C plus probability of C is equal to 1, which implies 7 times probability of C is equal to 1. So probability of C is 1 by 7, which implies probability of A is 2 times probability of C, so it is 2 by 7. Probability of B is 4 times probability of C by 2. Okay, it is 4 by 7. Fine. Okay. Now, if A and B are independent, P of A union B is 11 by 32 and probability of B is 2 by 8. What is probability of A? Right, what should you do? We know probability of A union B is probability of A plus probability of B minus probability of A intersection B. Since A and B are independent, this is probability of A plus probability of B minus probability of A into probability of B. What is probability of A union B? 11 by 32. Probability of A is not known. Probability of B is 2 by 8. P of A into P of B is 2 by 8 into P of A. Right? So 11 by 32 minus 2 by 8, this comes here. 1 minus 2 by 8, this and this are combined. 1 minus 2 by 8 is 6 by 8 probability of A. Right? Take 32 as the LCM. You have 11 minus 8 is equal to 6 by 8 into probability of A. 3 by 32 is equal to 6 by 8 into probability of A. So probability of A is 3 by 32 into 8 by 6. It is 1 by 8. Okay, probability of A is 1 by 8. Now, an equipment is made up of 3 independent components A, B and C. The equipment will function only when all the 3 components function well. The respective chances that A will fail 0.06 and the chance for B will fail is 0.08 and the chance that C will fail is 0.13. What is the chance that the equipment will fail? When the equipment will fail? It is given that the equipment will function only when all the components are functioning. Okay. So what is the probability that the equipment will fail? When at least one component fails, the equipment will fail. When at least one component fails, the equipment fails. Okay. So that is equal to 1 minus probability that none of the component fails. Okay. That is the probability that A will not fail and B will not fail and C will not fail. We have taken A as the event that the component A will fail. So the A bar represents the event that A will not fail. Okay. the components are independent. So you can write this as P of A bar into P of B bar into P of C bar. So what is P of A bar? 1 minus P of A. P of B bar is 1 minus P of B. And P of C bar is 1 minus probability of C. So 1 minus 0.94 into 0.92 into 0.87. That is 0.25. Okay. Now, a coin is tossed until a head appears. Find the expected number of tosses. A coin is tossed until a head appears. So the outcomes, see, you first write the outcomes. If the first outcome itself is head, you will stop the process. If the first is tail, you will toss it once again, and if you are getting a head, you will stop. If the first is tail, second is tail, you will continue the trials, and in the third trial, if you get a head, you will stop. Otherwise, you keep continuing like this. Okay. So here you are supposed to find the expected number of tosses. So the number of tosses here is 1, 2, 3, 4. It goes. And the probability values are here only one time the coin is tossed. Here you are tossing it for 2 times. The probability of getting a tail is 1 by 2 into 1 by 2 for head. So this is 1 minus 2 power 3. This is 1 minus 2 power 4. So this is your x now. This is your P of x. So expected value of x is summation x into P of x. Right? That is 1 into 1 by 2 plus 2 into 1 by 2 square plus 3 into 1 by 2 cube plus 4 into 1 by 2 power 4 plus etc. You take 1 by 2 outside. So you have 1 into 2 times of 1 by 2 plus 3 into 1 by 2 times power 2 plus 4 into 1 by 2 power 3 plus etc. This is of the form 1 plus 2x plus 3x square plus etc. The answer for it, which is 1 minus x the whole power minus 2. So you can write it as 1 minus, in the place of x you have 1 by 2 power minus 2. So 1 by 2 into 1 by 2 power minus 2. That is 1 by 2 into 2 power 2. Your answer is 2. So the expected number of tosses in this case is 2. Okay. Now let us go to the next problem. An unbiased coin is tossed until a head appears. Again the same is the situation. You are tossing the coin until a head appears. Okay. And find the expected number of tails preceding the first head. So number of tails preceding the first head. How many tails are there preceding the first head? 0. Here 1, here 2, here 3. This is your x. But what is the probability? Probability of getting a head is half tail, and then head is 1 by 2 into 1 by 2. Tail and head is 1 by 2 into 1 by 2 into 1 by 2. So this is your answer. Now expectation of x is summation x into P of x. So 0 into 1 by 2 plus 1 into 1 by 2 square plus 3 into 2 into 1 by 2 cube plus etc. You are taking 1 by 2 outside. This term goes 1 by 2 square outside. So you have 1 plus 2 times of 1 by 2 plus 3 times of 1 by 2 square plus etc. So 1 by 2 square, this is of the form 1 plus 2x plus 3x square. So you can write it as 1 minus x the whole power minus 2. So 1 minus 2 square into 1 by 2 the whole square into 1 by 2 the whole power minus 2. So it is a power m plus n, that is half power 0 equal to 1. Okay.